Hey everyone, today we are talking about how we factorize algebraic expressions by using the special product shortcuts we talked about last time. So basically it's the reverse process of expanding. So now they're going to give you the expanded answer and you have to work backwards to figure out what the original problem was. Okay, so here are your shortcuts from last time, but reversed, because remember, when we're factoring, we're just going in reverse of expansion. So now they're going to give us the expanded form of an algebraic expression, and we will need to factor it by getting it back to its original form. So let's review our shortcuts by solving this example together. So in example 11, they want you to factorize each of the following: a 25x squared plus 10x plus 1, and b 4x squared plus 36xy plus 81y squared. Go ahead and pause the video, see if you can figure this out on your own first. Okay, so I'm first looking at A and I see all pluses. And I see that 25x squared, I could find the square root of 25x squared, right? Before I would have squared, so now working backwards, I need to square root it to get back to its original form. 1, I could also square root that last term, right? So it looks like it's going to be one of those perfect squares with addition. So if you remember, that shortcut was a squared plus 2 times product of a times b plus b squared. So this kind of looks like that, right? I have an a squared because 25x squared can be square rooted. Its original form was 5x, right? Because 5x times 5x got us to 25x squared. And then the square root of 1 is 1. So I could have gotten this 1 by multiplying 1 times 1. Okay, so let's try this one out and see if it works. Okay, so this would be 5x plus 1 times 5x plus 1, or 5x plus 1, the quantity, squared. And let's just double check to see if it works. So we would take our first term and square it, 5x times 5x. So this is my checking process. 5x times 5x. Would it get me back to 25x squared? Yes. Plus 2 times my a term, 5x times my b term, plus 1 squared. I already know that 1 squared works. 2 times 5x times 1 is 10x. So it does work. So this is my answer right here. I can either expand it out or I can write it with the shortcut with the exponents. Okay, so again, we're going in reverse. Instead of squaring it, we are square rooting it. Let's try that with our second one. And then I also want to check and just make sure, right? Because if this was like 25x squared plus 9x plus 1, it wouldn't work. It would look like it worked, but it would be 1 off, right? Let's go to B. So this also looks like your perfect squares with addition, because it looks like I can square root these, and it has all plus signs, all addition. So let's just check that. 4x squared, can that be square rooted? Yes, it would be 2x. 2x times 2x would get me to 4x squared. Let's look at 81y squared. Can that be square rooted? What's the square root of 81? Well, 9 times 9 gets us to 81, and y squared, square rooted would be 9y. So let's just double check. So this would be 2x plus 9y squared. So to check it, I'm going to take 2x squared plus 2 times those two terms, 2x and 9y, and I'm going to add it to the square of 9y squared. Okay, 2x times 2x is 4x squared, yes. 2 times 2 times 9 is 36 times xy, yes. And then 9y squared is 81y squared. Yep, so this is my answer right here. Let's try example 12 here. Go ahead and pause the video and try it on your own first. All right, this one, I see some perfect squares on the front and the back, and I also see a minus sign for the inside term. So this one looks like it'll be the perfect square that involves subtraction. Okay, so as a refresher, it looks like this. Remember, the inside is minus and doubled. The last term ends up being positive because negative times negative is positive. So let's go ahead and try square rooting and checking our work. Okay, so I'm just trying to make this a little neater. Okay, t squared, if I square root that, I just get normal t, 1t, because t times t gets me to t squared. Square root of 49 is 7. So this looks like it should be t minus 7 squared. Let's just double check. Okay, so t squared minus 2 times t times 7 plus our last term 7 squared. Remember, we're ignoring the minus sign because this shortcut should take care of that for us. T squared, yep. Negative 2 times 7 is negative 14t, yep. And then 7 times 7 is 49. Yeah, that should be correct. Part B. Let me circle less vigorously. Part B, I'm going to take my first term. Remember, we're working backwards, so we got to do the opposite of squaring, which is square rooting. And then my last term, 36, oh, that's a q. Q squared. So what's the square root of 121? That's 11. Square root of p squared is p. 36 square rooted is 6 because 6 times 6 is 36. And q squared square rooted is just q. Okay. So then this would be set up as 11p minus 6q squared. So then to check it, I have 11p squared minus 2 times 11p times, we don't need the negative, 6q plus 6q squared. So 11 times 11 is 121, p squared. Negative 2 times 11 times 6, that's negative 22 times 6, that's 132, right? Negative 22 times 6, yep, 132 times pq, yep, plus 36, yep, this is 6 times 6, 36, q squared. All right, that's our answer. Very important that you double check because sometimes the special situation, the special case won't work and it'll just be a different type of factoring, which we'll learn in the next chapter. Okay, so always good to double check that your hunch is correct. All right, let's go on to this example. Go ahead and pause the video and try it on your own first. All right, this one, I only have 2 terms, so it's going to probably be the difference of squares, where it's a plus b times a minus b, and then remember the middle terms cancel out, so you end up with just the first term squared minus the last term squared. Minus because positive b times a negative b is a negative b squared. Okay, so same as before, going to take my z squared and square root it, so that gives me a normal z. I'm going to get my 16 and square root it, so that'll be a 4. So this should be z minus 4 squared. Okay? If I wanted, oh, my bad. I was mixing up my three situations there. Let me redo this. Z plus 4 multiplied by z minus 4. That's where the inside terms can be canceled out. Okay, so if we were to quickly double check that, it would be z squared. This would be plus 4z, and then a minus 4z, so that's why they're gonna cancel, and then subtract 16. So that does work out, okay? So it might help for you to just double check and make sure your inside terms cancel each other out. For b, find the square root of 49m squared and 9n squared. That should be 7m, and this one should be 3n. So 7m plus 3n multiplied by 7m minus 3n should get you this answer, which will have the inside terms canceled out. Okay, so you'll have 7m times 7m, which is 49m squared. You'll have a plus 21mn, and then you'll have a minus 21mn, and then a minus 9n squared. So then at the end you are left with 49m squared minus 9n squared. Okay, our last problem. We need to factor this, 3x squared minus 75. So here you're probably looking at this problem and you're thinking, I can't square root 3, I can't square root 75, so this is impossible. No, first, before you use your special cases, go ahead and see if you can first factor out a greatest common factor, or a GCF, and then you can see if you can use your special cases. Okay, so what is a greatest common factor between 3 and 75? Well, let's try 3, because if that doesn't work, we don't have a GCF, because other than 1, only the 3 is a prime number. It can only be divisible by 3 and 1, right? So let's take out a 3. So we're going to take it out and we're going to put it outside of our parentheses. So we're kind of going backwards and kind of creating a distribution. So if we were to take 3x squared and divide that by 3, we would just have an x squared left over. So inside we have x squared, so that later on we multiply 3 times x squared with distribution, we'd have 3x squared. Same with 75. What's 75 divided by 3? Let's see, it goes in twice, 25. It's like 3/4, right? 75 cents. Okay, so again, we took out the GCF, which was 3, by dividing both of them by 3. That's how we got this right here. Okay, so then now we can keep that 3 outside the parentheses. And then let's just factor this in here. Well, now I can factor x squared minus 25. X squared can be square rooted to x. 25 can be square rooted to 5. Okay, so but which of those special cases is it? Is it perfect squares with addition, with subtraction, or is it the difference of squares? Well, I do not have any middle terms, so it's got to be difference of squares, the one where it's plus and minus. So it should be x plus 5 and x minus 5. So this entire thing plus the 3 on the outside is your answer. Okay? If you don't keep in that 3, then it just is the answer for x squared minus 25. Okay? So again, if you feel like you cannot factor any of the problems, try taking out a GCF first.